streaming. Okay, hello folks. I think you can hear me. I think I am streaming on the internet right now. If you are just joining me, welcome. If you're watching this later, welcome. I'm still configuring some of the settings, so I'm just going to take a couple more minutes. Yeah, so hang tight while I set up the stream, or feel free to skip ahead until you start seeing content. Thanks for your patience. Okay, so welcome back, folks. What a crazy couple of weeks it's been. It has been so snowy and blustery, and I hope you're all doing a good job of staying cozy and dry and not going out anywhere in this nasty weather. I'm still just taking a couple more moments to make sure I have everything set up. It looks like I do. So I will be ready to go in just a moment. Just want to make sure we're all live. I don't stream very often, as you can probably tell. But welcome. Okay, so yeah, it's been a crazy couple of weeks. I am doing this stream on behalf of both classes that I teach, right? Both Fordham and SVA have been really hampered by this blizzard and have been kind of knocked off track. So this is going to be kind of like a grab bag of all of the kind of material which we were going to cover over the next couple of days in these courses. And it should also just serve as a helpful reference point for this kind of beginning work we're doing in Godot and coding, right? We have, in both of these courses, we've started to really look into how to make things move, right? How to make things actually interactive with code, how to start structuring our projects via scripting, and we've started thinking about our 2D games. But at the moment, our skill set is still feeling fairly fundamental because, in part, we haven't really explored all the different types of things we can do, right? We have started to see how we can start interacting with things through simple conditional logic and if statements and all that. But in order to really get sort of working with Godot and start building out interesting structures, we need to start utilizing nodes more and the different functionalities that they have. And so this stream is going to be kind of a broad introduction to it'll be a bit of a refresher on the coding work we've already done, right? I'll kind of review the Lab 2 sort of fundamental template that we're working with, and I'll kind of step through again how to get up and running with a bare bones coding example. But then it'll get really fun because we'll start just playing around with a bunch of different nodes, and I'll start showing you all the different types of things that we can do with a little bit of code and a lot of magic. I don't know, the nodes in Godot are pretty powerful, and we don't actually need to know too much in order to start building up some really interesting and kind of complex stuff. So hopefully today we'll cover definitely more input, potentially some physics systems, and maybe even some animations with sprites and animated sprites and tile maps. So that should be a lot. We'll see how far we get. I'm hoping to do this for about an hour, but time will tell, and we will have a good time regardless. So, right, I guess what I'll do is I'll just sort of open up Godot, and I will create just a blank new project for our reminders. This also looks kind of crazy, this theme, so I'm going to change the theme to be a little bit more, a little easier on the eyes, I think. So I will go to the color palette and go to default, and that'll be good. I will also now just go back to the main menu, right, to the project picker. And I'm just going to go ahead and create a blank new project. I'm going to call this, I don't know, coding review, and nodes. Okay. And for the moment, because I'm showing this to you for multiple classes at once, I'm not going to put this immediately in either of our class repositories, but I will link to it on both of the syllabi shortly. But for now, I'm just going to put it inside of my base teaching folder, and I'll put it in a better spot for you all to have access to it momentarily, right? So again, I'm still going to use the old compatibility renderer, right? That usually gets the job done for most of our various needs in terms of the level of coding that we're working with, the complexity of code. So I'm going to go ahead and hit create. And then this is going to take me to the editor, right? And as a reminder, I think what I'll do very briefly is I will just remind us how to meet these sort of like introductory criteria for our Lab 2 assignment, right? For the Lab 2 assignment, we want to have a node with some code attached to it that responds to user input using an if-else conditional logic statement and a exported variable. And I know I might be throwing all that out pretty quickly, but hopefully we should be orienting ourselves to what that feels like, right? In Godot, that means creating a new scene, right? An empty new scene. Then you want to have a node, right? So I'm going to drag in this little robot as my node for my to start with. I'm just going to center it a little bit more. Then I'm going to right click and attach a new script to it and hit create. I'm gonna hit create. Come on, Godot. There we go. I'll just click on it and hit create. Right, and we'll see that we now have this nice little empty template, right? And as a reminder, in Godot, we can always create new variables, and variables can hold all sorts of information. We create a variable by writing the keyword var at the top of our script, followed by the name of our variable. So I'll say like my var variable. And we say equal to the value that we want our variable to be, right? And a variable could be a floating point number, or an integer, or a floating point number. A variable can be a string of information, or a variable can even be this thing called a Boolean, right? A true or false value. And variables can be many other types of information, but these are some of the most bare bones get you up and running variable types that we have, right? So here we have this variable. I'll make it like 4. As a reminder, we also have, in this template, we have a nice, easy entry point to 2 of these key introductory functions, right? We have the ready function and the process function. And as a reminder, the ready function happens once at the beginning of every like run through the project, when the node enters the scene tree for the very first time, we fire the ready function and we execute any code that's written in there. So we could say like, you know, maybe we have an initialization thing that's getting this node ready, and part of that is the node says, oh, I'm getting ready, right? And then maybe we also want to have it, you know, check the status of the variable, and we can say the variable is, and I'm going to do comma here, and then I can also put in the variable. And what's nice about this print function is you can give it as many arguments as you like, and it'll stitch them all together into one outputted print line, right? So if we were to run this code, first I'll save this scene, I'll call it main, I'll run the whole project. I don't have a main scene yet because I just created it, so I will select this current scene to be the main scene, right? And now when I run the project, we see that both of these things happen, right? We printed out the, oh, I'm getting ready string, right? That's this data type right here. And we also printed out this other string with this number, right? The variable is 4, right? And again, these could be anything. So this could be a string. We could say, you know, elephants or whatever. And if we ran the code one more time, we would see that now we print out the value of that string, right, instead of the number, right? So we have this ready function that fires at the beginning of the you know, when this node enters the scene tree for the very first time. We also have the process function, which happens once every frame, and frames are rendered at typically a rate of around 60 a second. So if we print it out, you know, our variable, my variable, every frame, you will see pretty quickly that we have a bunch of elephants, right? This is we're suddenly up to 200 elephants in under 10 seconds, which is pretty powerful stuff. We can not only, right, just access variables, we can always modify variables, right? So if we want to make this instead like, I don't know, a number instead of a string, right? So I'll make it the number 0. And then we can always say my variable equals itself plus an amount, right? So I'll do +2, and I can print this out. And this is a trick that we use all the time to increment, to increase our values over time, right? So now if I were to run this code, you'll see that we are increasing by 2 every frame, right? And our numbers, we got a number that's going up, which is a pretty sort of fundamental type of behavior that we can quickly use to then create things like motion, dynamism, you know, all sorts of stuff can come from the fact that we can just simply have changes in the state of our code over the course of every single frame, right? And the simplest way to do that is just by having a number go up, but you can do all sorts of interesting changes every frame, right? You could sort of say, you could make a number go down, for instance, right? And now we can make the number go down every frame, right? You could multiply the number every frame. You can do a whole bunch of different types of math, right? There are lots of functions you can use to generate like random numbers, for instance. So maybe I want a random number. I can just say random, so we have randf, which picks a random floating point number. Random f range, which picks a floating point number in a certain range. And then we have the same thing for integers. So maybe if I want a random integer in between, like, let's say 0 and, I don't know, 500. Okay. And then we can see that now every frame, when we run it, right, we are going to call this built-in function to pick a random number. This function is going to return that number and assign it to this variable. And so now we can do stuff like see that our number is just kind of going crazy every frame, right? And we also have the ability to use these numbers, you know, not just as internal states, but as then we can sort of assign them to properties that nodes have to create behaviors that we can actually see and perceive, right? So a very simple thing we could do is maybe assign this variable to our position, right? So I'll say position dot x equals my variable, right? And this is going to look suddenly very crazy because every frame we're giving our x position a random value, right, between 0 and 500. And so this is going to look kind of like we see this node kind of bopping around all over the place, right? Which is kind of interesting. Maybe that's like a behavior that you want to have happen, right? You could see maybe if we pick a smaller number and we sort of say, maybe we want to have it to be, you know, a random number between 0 and 50, but we'll also add 200 to it. So we'll scooch it over a little bit to the right, and we'll just make it wiggle around a little bit, right? That's kind of an interesting behavior, you know. Maybe you need an earthquake scene or something, or maybe you need an attack or something. You can create all sorts of interesting behavior with code, but just by changing, you know, what sort of values or variables by manipulating those variables and assigning them to different properties, right? So this is kind of like the beginning of starting to work with code. And again, you know, this is still not particularly interactive, right? This is not like a very sort of compelling thing, and it doesn't. And the reason why it's not interactive is it's literally not interacting with us, right? We are simply sort of creating a static animation right now that is not actually doing anything, right? It's not actually responding to our input. Oh, we have somebody in the chat. Hello. I don't know who this is, but hello, welcome. I'm so glad you're here. It's good to see you. Feel free to ask any questions. Thrilling, a viewer. This is great. As you can see, I don't stream very often because I'm delighted by having one viewer. In any case, right, so we have this kind of number, we have this variable that we're increasing. We can very easily make this interactive by starting to tap into the input system, right? This input function, this input class that has all of these associated functions within it that get us a bunch of behavior, right? So we already started to look at one. I'll say input dot is action. Well, I'll show you a new one, right? So we have these sort of is action just pressed things, which I've started to float right to you all. But this sort of UI accept language, this is maybe a little bit confusing. What I'll say is, right, this function is essentially checking to see whether or not we have pressed the UI accept action, the space bar by default. And if it is true, it's going to do this thing, right? So if we're going to say if input is action just pressed UI accept, then we're going to do this thing down here. So maybe what we want to do is we want to just sort of make our little sprite wiggle around only when we press the space bar, right? So in order to accomplish that, I'm just going to set it up like this, where we say that if we're pressing the space bar, then we're going to pick a random number and assign it to our position, right? And so if I do this, we see we have this object that sits still, but whenever I press the space bar, it bops around, which is kind of interesting, right? Maybe this has to happen when we are, you know, you want to have a character that can move randomly, right? Or you want it to sort of respond to some sort of like reaction from the environment, right? We already have the bare sort of fundamentals of something that is inherently a little bit interactive, right? But as I was sort of getting to mention, right, this sort of input is action just pressed, what does that mean? This kind of points to a sort of more abstract concept called the input mapping system, which I'll show you in a little bit, but it's something that might be even sort of more straightforward for you to grasp right away. Is the input system has another function called input, right? We're referring to the system, then we're getting the function is key label pressed. And this is basically saying, is the literal letter of the key that we're going to pick right here getting pressed, right? So for instance, is key D being pressed, right? I'm going to put this in here and then say print D was pressed. Okay, save that, run this. We still have our spacebar action, right? But we also can now press D, and we'll see that D triggers these events here, right? So that might make a little bit more sense to your brain, right? Is this button literally that we're pressing on the keyboard getting pressed? But where the input system is helpful is, you know, oftentimes in games you want to have like characters that are controlled via a couple different keys, right? A typical example is moving around. Sometimes we want to be able to move with like the arrow keys or the W, A, S, and D keys. And that's where the input map system will really come into play. And I think I'm kind of getting way ahead of myself here, because what I'll do is I'll sort of take a step back and build out a basic character moving script. And I'll do it with this input mapping system, and I think that'll sort of help elucidate, what it's useful for and how to use it. So we have these if statements, right? Again, we have an if statement, and then we have a condition that we're checking for, and if the condition is true, then we're doing this. And that's a really handy pattern to use for a simple character controller, right? So something that we can do kind of right off the bat is we can say if input dot is action pressed. And right, we see that we have this just pressed and this pressed function. The difference between these two is that this fires once at the moment of pressing it, and this one fires and continues to fire even when you're holding down the button, right? So I'll actually show you both. We'll say UI accept for both of those. We'll say just right here. I will put a colon, and then I'll say print started. We can say, I'll even do this, I'll say started pressing, print holding, and then there's another function too that you also have access to called, what's the problem here? Is action just pressed is not found. Sure it is. I think I just typed something wrong. Dot is action just pressed. All right, Godot seemed to be a little confused. The final function that you also have action to is action just released. So you can say input dot, oops, is action just released. UI accept. And so now this will be a sort of cute little example. Stop pressing. We can see that we have this code that's going to run, right? Nothing's happening by default. I am going to press space, and we'll see very quickly. I'm going to press space. I'm going to press space. Why aren't I pressing space? Oh, I have a very I'm sorry. I have a very silly space button on this keyboard. I need to pick a different key. That's my fault. I'm just going to I'm going to choose the left arrow. If you're really curious, when I hold space, it actually turns into a different key. So that's actually just not going to work for this example. But it will work with the left arrow key, so we'll do that. Okay, so we have UI left. We'll try it again. I'm going to press and hold the left arrow key. And you'll see that as I do that, right, at the top of this, when we first did it, we started pressing it for 1 frame. Now we can see that we're holding it, and then if I release it, it'll stop pressing it. So that's exactly how this flow works with these functions, right? If just pressed is the starting moment, action pressed continues to poll the event throughout the duration of you holding it, and released fires at the moment when you let go of the button. So feel free to use those in whatever way you want, but if we wanted to turn this into movement, we're going to want to turn our attention to the input mapping system, right? Because we want to create this example where we have these this character that we can move with a couple of different keybinds. So in order to get to the input mapping system, what we can do is we go to our project settings, okay? And we go to this input map tab. And you'll see that there's nothing here by default. If we toggle this show built-in actions, you'll see that we have all of these things pop up, which are these actions that we've already started to look at. So this UI select action is just an action, and it's like an abstract action that has been attached to the spacebar event and the joypad button 3 event. There's also UI accept, which is bound to enter or space. Close, there's focus, there's tab, there's left, right, up, and down. But oftentimes in games we want to make our own actions. So what I'll do is I'm going to go and turn off the built-in actions. I'm going to go to add new action, and I'll say move left, and I'll hit return. Then I'll type in move right, return, move up, return, and move down. return, right? And you can see that we have now created these 4 actions, but there are no input events being assigned to those actions. So in order to do that step, you now want to turn you want to go over to this plus button, and click on plus. And then now, when this window pops up, this window is listening for an event input right now. So you basically want to press the button that you want to have be associated with your input. So right now, I'm going to press the left arrow key, and you'll notice that it catches that, right? It says left, okay, and you can say yes, good. And now you'll see we have associated the left arrow key with moving left. Hello, we have another person. Welcome. Are you folks from SVA or Fordham? I see .designs, that kind of implies SVA to me, but I'm not sure. I'm glad you're here. So we're associating input mapping buttons with our we've created these input maps, right? And we are now associating key presses with these actual actions. So we have our left key being pressed, which creates our move left action. I'm also going to click plus again and press A. Because I'm going to use W, A, S, and D as well. And you'll see that when I press A, it catches it. So I can say, okay, yes, SVA. Cool, right on. So we have left being associated with move left and A also being associated with move left. And this is really nice because this allows us to use either the left button or the A key. And pressing either of those will tell the input system that this move left action has occurred, okay? I'm going to do now the same thing for right, up, and down. So I'll go to right and press D and hit OK. Then I'll click plus again and press the right arrow key. Then I'm going to go down to up and press W and hit OK. And then I'll press plus, and then I'll press the up arrow key and hit OK. And then finally I will go and press S. And then I'll click it one more time and press down. Okay, so now you'll see what I've done is I've created these 4 actions, move left, move right, move up, and move down. And I've tied 2 keys to each action, right? I've tied S and down to move down, W and up to move up, D and right to move right, and left and A to move left. Now I can hit close, and then back here in my code, I can say if input dot is action. I'm going to go down to pressed, so I'm using the arrow keys and hitting return. And then now you'll see what's nice is that any actions that we have actually created are just going to pop right to the top of the list because Godot is assuming that these are more important to us, right? So I'm going to take my move right action, I'll start with that one, and say yes, if we are moving our, if we are pressing our move right action, let's in fact now move our character. So I'll say position dot x plus equals, right? Again, that's that shortcut for saying itself plus an amount. And we have my variable. I'm actually just going to go up and change my variable to something a little bit more useful in terms of nomenclature. I'll call it speed. And then I will also go ahead and export that. Nope, not export. Var. And now we can see that it has popped over to the side. It should have. Where'd it go? Or click it out and again. Where is it? Export var speed. Oh, it's, there's an error, so it's not compiling. So now finally down here, I'll say speed. Okay, now if I save, right, and this line's now annoyed because it's not called my variable anymore. So I'll just delete that whole line, that's fine. Okay, now the errors have gone away, so it goes ahead and makes this speed for us, right? So we have speed over here, and we can set that to like 10 or something. And I'm just going to go ahead and fill in the rest of this little code, right? So I'm going to copy this and paste it. And then instead of move right, I'll say move left. And then instead of plus x, I'll say minus x. I'll highlight both of these lines, copy, and hit return and delete and paste. And then instead of right, I will say down. And instead of x, I will say y. And instead of x, I'll say y down here. And then over here, instead of left, I just have to say up. And now, I believe if I run this code, you will see I have a character who I can move with W, A, S, and D. or the arrow keys, right? And that's pretty handy. Yeah. So that's a really nice way to create your own input actions and to associate them with input functions. And if you're trying to do this as a means of getting to Lab 2, this is actually good for Lab 2, right? For Lab 2, all we really needed was a node with some code attached to it with an exported variable. There it is. And some conditional logic that responds to user input. And this would work pretty well for that. And it would also set you up pretty decently to have a, like a very simple character. And this is kind of good for, again, our introductory stuff, but there is so much more that we are trying to do oftentimes with code, right? And there's so much more that we want our games to be able to do. And so in order to kind of start building that out a little bit, again, we need to start looking a little bit more closely at all the different nodes available to us and what they have to offer us. And yeah, it's not going to be a very elegant transition right now because there's just a bunch of nodes that I want to start telling you about. So with that in mind, let's just dive in, right? One, frequently, right, if this were a game, one sort of critique that we might have of this game is that it's kind of boring to just have a game where you have a character who just leaves the screen if we walk, right? Typically when we have our player, we want to have our camera be able to follow our player around and do stuff with them, right? And we want to be able to make worlds that are bigger than just like the square that we're in, right? The easiest way to do that is to start using a node called the camera node, and the camera node is very powerful, and it's very easy to do. All you really need to do is add it to a child, right? So I'm going to get camera 2D, and we'll see that as soon as we have a camera 2D, we actually have a very bright pink square, and that square is overriding the default rendering position of the viewport, right? So instead of just drawing this square, we're now going to draw this square, this camera square, right? And let's go ahead and do this. Let's get a background. I'll use a very simple background for now, and soon we will use prettier shapes, but we'll just say we have a colored rectangle. I'm going to make a very simple level for us, right? I'm going to take it and put it out. I'll make a new node, just a blank node 2D, and I'll call this level. And what I'm doing right here is I'm just trying to create a little bit of organization even in this simple project because it's easy to get things confused. So now I have this node that's going to serve as like my level sort of container. And then I can take each of my objects that I want to have in my level and move them around and kind of make the arrangement that I want, right? Sure, I'll have it like that, whatever. Great, so now I've made a couple of squares, right? And we'll see what's nice about having this camera is that when I run it, right, now I have this camera that has centered my player on it. And when I move my player around, you'll see that the camera just automatically follows them. And the reason why we get that is to go way back to our sort of original concept of how nodes work, right? Nodes just inherit properties from their parents. And so if we have a parent that moves, any child node that has a spatial component will follow it. And so the camera just follows it around kind of magically. If you don't want it to be centered, you can always offset your camera. So you could take this and kind of drag it up a bunch, right? That's gonna take a long time, so maybe I'll make it just type in here 300, right? And that kind of scooches it off to the side. You can also change the zoom of the camera. And we'll see, maybe I'll make it 200. No, let's go negative 200. I kind of want this character at the bottom of the screen. That's kind of fun. And then I'm going to hit play and move around. Right, and we'll see now we have a zoomed out camera. And this is already telling a very different story, right? You can really tell a lot, you can do a lot just by focusing on your composition, not necessarily focusing on the fanciest tricks in the book, but even just by sort of changing your perspective, by zooming in and out, by offsetting things, by using certain objects and certain sort of images, you can just create a very interesting story, right? So that's one sort of starting thing, right? Is this idea of using a node that is that is sort of attached together with this this picture, right? But we still, you know, this is still fairly rudimentary because we're not actually kind of doing anything. We're just sort of like flying past these objects, right? And it would be really great if we could sort of do things like detect when we were like entering options. Well, I'll show you one more node quick, before we, because that's gonna, if I go down that road, it'll sort of open up a whole other new can of worms. But there's a lot of really straightforward nodes that are also super useful. And particularly if we're sort of building out this idea of like a player, right? I'm gonna actually right click and turn this into its own scene, and I'll call it player. Okay. Now I can open this and say like, that's the sprite, that's great. Maybe we wanna have like a simple heads up display, right? Oftentimes we want to accomplish that by having like pictures on the screen or text, and we can do both of those really easily. So one thing we can do is just create a new label node, and a label node you'll see is also a green node, and again, green is sort of reserved for user interface. So you can see once we create our label node, we have this kind of little text box which we can kind of drag around wherever we want. And we can also do stuff like, say, health, right? And we can put some text up here, right? Health equals 100, right? And this is pretty tiny text, but we could make this square a little bit bigger, and then we can also, if we very quickly want to adjust it, I believe we can just go to label settings and create, oopsies, close this. Click on this little caret and do some new label settings. Then we have to open up those label settings. And then from here you can do things like change your font size, whee! Change the color, whee! Give it an outline. Hold on. Give it an outline, you know, you can give it a shadow. You can actually do a lot. Let's see, make the shadow nice and big. Maybe like 6, 5. And then try offsetting it a little bit. Yeah, there you go. You can start to see it. And you can even add like outlines and shadows and the stack. You can go really nuts. And the simplest way to work with fonts is you could try and use a system of font, but that's not very dependable, right? It's hard to package that. So I recommend just going and getting a font file, right? So I will go to, I don't know, the font. I think that's a good, easy one for examples. Da font. Squeaky, yeah. Use the squeaky font. That feels pretty apt. I am going to extract it and unzip it. Let's see, teaching. Where did we save this? Coding review notes, right here. Yeah. So I'm just going to extract it to here. And then now you can see once we have extracted it as a font package, you can see that we have here the OTF that we can use, and I believe it is simple as just dragging it into our font. And that, okay, this font seems to have watermarked numbers, which I hate. I've never seen that before. That's a crazy choice font. Gross. Well, the point is, right, if you find a font that doesn't watermark your numbers, it's very easy to work with. And now I need to change this because I need to show you numbers. So I'm just going to get rid of the font. But, you know, fonts are very straightforward to work with. You just go find them, drag them, and drop them. And what's nice, again, also about this sort of compositional setup, you know, this, yeah, compositional in the sense that, like, you compose things together by sort of having children that respect their parents' properties, if we run this thing now, we'll see that this label node also follows us around, right? So this is already like a decent HUD, right? A heads-up display. You probably want to figure out a way to put this in front of the objects, right? And the simplest way to do that is to just swap the order that they're getting drawn in. So you maybe draw the level behind the character, right? And we can already see that this is pretty nice, right? But, you know, again, we can go a lot further just by introducing a few more concepts. Something like, you know, we have this number, this sort of static number that's here right now, but it'd be really nice if it were fairly straightforward to be able to have this number respond to changes in our environment, right? Maybe this isn't health, but it's a score, and we want our score to go up when certain events happen, right? And once we get to that point where we need to sort of start telling nodes what to do, then we have to sort of introduce a new type of concept, right? Because currently our code has been relegated to just defining behavior and properties that are associated with the node that we're attached to, right? This code is moving this node and is talking about stuff within this node. And we currently have no idea, if we have code that's up here, how to like get down here and change this, right? And so that's kind of the next sort of big thing that we have to talk about. Oftentimes when we have code in our games, we have code attached to a node, and then we need to go and either ask another node below us to do something or tell a parent node about something that happened, right? And there's two kind of major ways to do that with nodes. If we are trying to reach down into a node, we can do so by calling or referring to properties inside of child nodes. And if we're a child node and we need to sort of send information up, we can do so by using something called a signal. Okay, and I'll introduce both of those right now. And this might feel a little hairy, right? I know that I'm introducing a lot of concepts over the last couple of weeks, and this particular chunk of how to start communicating in between nodes, this might be the most kind of complex coding part of the whole semester, I'll say. This concept of how do we share information between different nodes. It's a little bit weird, so just bear with me and trust that this is a video, right? You can go back and rewatch this as many times as you want, right? So I'll give like a really practical example, right? We have this character, right? And maybe this label is not just a label, maybe this is gonna be our score, right? I want our score to be this. We'll just keep it as a very simple number for now, right? 0, okay? And so when we run this game, we have this score that is 0, that just kind of hangs out, right? And how do we make our score go up, right? How do we make both this, like how do we have an event that triggers our score going up, and then how do we register that event to the label and then show us the player that thing, right? So the first thing, right, I'll just create a variable attached to my player called score, okay? Score equals 0, okay? And now, actually, maybe I'll start at a score of 100, right? Now what I'll do is, at the very beginning of my game, I'm just gonna show you how to go from having a score that's, you know, saved inside of your player node and going down into your score label and updating the text of it to reflect your variable, right? So the first step towards doing that is we have to get this node as a variable to work with, right? So we can use this, what we can do is we can create a variable, var like score label, okay? And we can say we want this to be equal to the node, get node, and then you'll see that from here, Godot is smart enough to give us the names of all of our children, right? The dot refers to ourself. Then we have camera, 2D, and we can also say score. So I'm gonna go down to score. And now we have score as a variable, right? This variable is, again, I said variables could be anything. Variables can also be nodes themselves, right? And so we have this variable that we can do all sorts of stuff with, right? So for instance, if I printed it out, We can see it. We can see it in the console. We can also change the visibility property. So I'll like hide it, for instance. So I'll say score label dot hide. Okay. Now if I ran this game, you would see, right, it's hidden, right? We hid the label. We can also see here's the label getting printed out, right? This is like the sort of internal reference to the variable, right? This sort of is how Godot sees it. It's like its name, basically. But you can see already that we're able to get a node as a variable and then act on it as a variable, right? And this score label has a property, text, and so we can set that property in the same way. We can say score label dot text equals my high score, right? And now if I ran this, you'll see that this text up here says my high score, right? Even though we didn't type it in at runtime, we're changing it to be whatever that variable is, right? And if you're sort of, you might notice that this text property is a string, right? And if you're also, what I should start saying is if you are confused about how any of these nodes work or what their properties are, there are lots of good ways to learn about them. So for instance, you can always hold, I think, Control on Windows or Command on Mac. And click, well, maybe not. I think you can hold Control or Command on Mac. I'm on neither, so pray for me. But typically you can hover over these and click on this to get to the documentation on how that label works. You can also right-click on the node and go to Documentation. And this shows you all of the properties that this node has. And it shows you that this text property is a string. We can click on it. We can go and we can say, what is this string? Oh, this is the text that's going to appear on screen, right? So we can see that this, this score label wants to be text, right? So one issue that we might have is if we just tried to give it the value of our score, Godot will get a little annoyed with us because that score is in fact not a string, it's a number, right? This is an integer, not a string. And so if we ever want to turn a string into an integer, we can use a very handy, or an integer into a string, right? Or a floating point number into a string. We can use this very handy string function, str. You put in any sort of information, any sort of variable, and it'll convert that variable into a string. So now we can say score label.text equals the string of score. And so now we will see our score is set to 100, right? And this is a pretty handy way to to manipulate and display data back to our user, right? So maybe we have a very simple game where whenever we move up, our score increases, right? So now I can say score plus equals 1, and then we also want to update the variable, the label, right? So I can now say score label dot text plus equals, nope, or equals string of score. And so now I have this game, super advanced game that's already broken. Why is it broken? What did I do wrong? Ah, yeah, right. So, so part of our issue here is we have created a reference to this node only inside of this function, right? And typically when we have variables, we want to create them outside in this global scope, or we need to create a local reference to it. So we can also just go to here, we can copy this and paste this down here, and we can say var score label equals get node score, and then score label.text equals the integer converted to a string. It's getting a little hairy, I know. But now we have our number, right? I can move around, and if I go up, we see that our score goes up, right? We just have a score that increases whenever I go up, which is pretty cute. But let's now say, like, what if we wanted a score that increased off of sort of interacting with a certain area, right? One of the most classic things that we have in games are like stuff you pick up that makes score go up, right? A coin or mushroom or whatever, right? In order to create something like that, you know, we're starting to see the building blocks here of like score. We have this thing that we can reach down into, but we now need to start having nodes kind of like reporting different things to each other, right? We want to have like, it'd be really great if we could come up with some sort of way to detect when something has entered like an area, right? Like if we have entered the area of the coin, maybe we want to make the coin disappear, increase our score, and that's it. We want to make the coin disappear and increase our score, right? One very straightforward way to start doing that is to use a new node. I'm going to introduce two nodes right now, called an area 2D. And you can think of an area 2D almost like a motion detector, right? It's kind of like one of those sort of like security alarms. Like when you step into a certain area, it goes off. It sort of reports this like event that has happened. But this is not actually the area. It's a little weird. It's a little confusing. But this area 2D node is not actually the literal area. Okay, this is just the like security guard. You also need to create your little area of detection. So we're going to have another node as a child of the area 2D called a collision shape 2D. And a collision shape 2D is the specific shape that the area 2D is going to be listening for like entering and exiting. But then once you create a collision shape, it's going to complain and it's going to say, what's the problem? We need a specific shape for our collision shape, right? So now, once we've created our collision shape, now we have to go over here to this shape property and actually pick a specific shape we want to use. And you might think that that's kind of dumb. Like, why would we, you know, why can't this thing come with just a shape built in? But what it allows you to do is it allows you to pick specific shapes depending on, you know, what your actual thing is you're trying to make. Like maybe you actually want to get pretty specific and have a square that is exactly the size of your character, right? Or if you had a circular character, or if you had like a capsule, or you can make all sorts of complicated shapes too. So the collision shape doesn't come with a shape predefined because it allows you to just use this one node with a variety of shapes. And the area, the collision shape doesn't come as a part of the area because we actually use collision shapes for a bunch of stuff. And we're able to, by separating these two things, we're able to have a collision shape that we can use for an area, but we also have collision shapes that we can use for things like running into stuff, which I'll try and show you in a little bit. But okay, so we have this area, right? This like kind of like motion detector, and we have this collision shape, this thing that is like the actual area which is going to detect its motion, right? But we need some sort of way for this node to tell us when this detector has gone off, right? And this problem, this is getting a little kind of complex, but this problem is something that we run into a lot. Is like, how do we get a node to tell another node something has happened, right? Even before we even do this sort of more complicated area example, right? Maybe we want to have like a simple timer, right? We want to know when a timer goes off. Like maybe with this example that we have, right? Maybe when we, after we move for a little bit, we want our character to disappear, right? And we need like a timer to tell us when it's time to disappear, right? So I'll show you another node called a timer. That's very simple. This is just a timer. It's called timer. It has a length of time that it goes for. You can decide if it happens only once or if it's kind of like a metronome that keeps repeating, and you can decide if it starts automatically or not, right? So we have this this very simple timer, right? I'll say it's like 5 seconds long, and I've set it to happen one time and for it to start automatically, right? But the problem that we have here is that our code is up here, right? So if we just kind of ran this scene, we would see that we have this scene that's happening, right? We can even see we have the timer, and the timer is working, but it's not like reporting anything anywhere, right? It has its own functionality that it's doing, but it's stuck inside of this node. and we need to sort of listen to it. All right, we need to listen and respond to its events. And the way that Godot does this for us is with this sort of final new concept called a signal, right? If we look back to our code of sort of reaching down into this score label, right up here in our player code, we got a reference to our score label. We said we want this node score, so we kind of reached down in here and got this, and we updated its variable, right? We said our score.text, wants to be this number, right? So that's one way of sort of communicating between these nodes, reaching down into a node. But what we also need to start doing is having nodes being able to reach up to their parents. So like with this timer, for instance, we want it to be able to say, hey, I'm done with the timer. Are you listening, parent? And so the way that we do that is with signals, right? So when one sort of helpful distinction between these two concepts is you can think about if you're sort of reaching down into something, you want to use this method of like getting your node, right? And if you are broadcasting up to your parents, you want to use this method called a signal. And the way signals work is there is this signal tab on the inspector, which we can go over and check out. And we can see that every node has some signals that it knows how to emit. And the signals are different depending on the node, right? Area 2D has a bunch of different signals. This label has some signals. The camera has some signals. Timer only has one really useful signal, which is timeout, and that is basically what happens when the timer goes off. And you can kind of think about all signals as like talking to a walkie-talkie, right? If I'm the timer and I'm supposed to count to 10, then when I get done counting to 10, I say, I've just finished counting to 10, over and out. And I sort of broadcast that into the walkie-talkie. I send that signal out, and whoever is listening to me can tune into that frequency and then do stuff when they learn that from me, right? They can you can listen to me or you can choose to not listen to me, right? So a signal is kind of like a walkie-talkie, right? And we work with it in the following way. If you're particularly code savvy, you can use code to sort of connect your signals. But if you like kind of clicking around, I suggest using this way instead. It's a little bit more straightforward. So you want to click on the node whose signal you want to find, right? Then go find, open the signal tab and go find the signal you want, right? And for the timer, we want timeout, right? Then you double click on that signal, and it'll pull up a list of all of the available parent nodes, and the only ones you'll be able to select are the ones that have scripts attached to them, right? So I'm going to click on the one that already has a script, and then I just hit connect. And you will see that what it has done, it has now created this function called onTimerTimeout with this little green arrow. This green arrow shows you that it's connected to this source node. And this function is going to happen when this signal is done, right? And a lot has happened, right? We have this little Wi-Fi thing now. This shows us that there's a signal that we're using. We have this green little onTimerTimeout. If we click that, that'll take us to this function right here. And so what we can do is we can now say, print time is up, right? And then maybe even we'll just like hide the whole player, right? So I'm going to make this very simple game where, when we have like 10 seconds to move around, and then we're going to run out of time and disappear, right? So now we start the game. The timer's already started. Time is going up, and then when we get to 5 seconds, we disappeared and it printed, right? And that's all because we have this node down here, which is doing its own thing. It's a timer, and it starts automatically, happens once, and lasts for 5 seconds. And when it's done, it emits this signal. It sends out this little text through a walkie-talkie. And we are listening to that signal from this code up here in this script, right? And so when this code happens, when this signal gets emitted, this node up here is listening for that input, and then it's doing this stuff down here, right? And I know this all might have seemed like a tangent because it's like, where did we go? How did we get here from Area 2D? The reason why I had to sort of take some time to explain that is Area 2D is entirely signal based, right? If we look at the Area 2D itself, you'll see it has a bunch of signals, including a signal for when another Area 2D enters it, or another area exits it, or when a body enters it or exits it. All that sort of stuff, right? And so we're trying to build out this little example where we have like a maybe like a character that's moving around that can interact and like pick up stuff, right? And one of the most straightforward ways to do that is with this node Area 2D, and by using this concept of a signal, right? So where are we? How long have I been going? Looks like we are at about an hour. Okay, go a little bit longer. We'll put all these pieces together. So, so in order to work with an Area 2D, right, we want to use its signal. So I'm going to use this area entered signal. So I'll double click on it. I'll pick on the node that I want to attach it to. So I'll pick on the player and I'll hit connect. And you'll see that we now have this on Area 2D entered function that happens where we both have a reference to the actual area that enters the area. It's getting a little weird with our multiple areas, but we have one area is being detected by the other one, right? So whatever area is going to make contact with this square is what is going to be returned by this function here. So we could access that variable and do something with it. But for the moment, what I'm just going to do is I'm going to take my my score code, right? And I'll also take a moment to say, right, as you can see, we're already doing this thing a lot where we have to say, you know, variable, we make a new variable, we go get the name of the variable, and then we do stuff to that variable, right? We're already doing that a lot, and anytime we do something a lot over and over again in code, typically there's an automation or a shortcut for it. This is no different. So we could, in this case, if we want to update our score label again, right, we could say var score label. You know, we could type it all out and do exactly the same thing. We can also just use the $sign. And the $sign is literally just a shortcut for exactly this stuff, right? As soon as I type $sign, oh, sorry, we don't even need to say var. We just say $sign. Here, I'll try again. $sign. Then as soon as I start saying $sign, you'll see that I have all of my children available to me, right? I have camera, score. So I'm just going to go down to score and hit tab. And we say $sign and then name of node. And then we can just interact with it right here. So I can even just say .text equals string of score, right? And this one line here of saying $sign dot property is exactly the same as saying var, you know, make a new variable, go get the actual node you want, and then interact with that. So all of that is to say is like oftentimes if you just want to interact with a node, you can use $sign. And an even easier thing you can do sometimes is if you're not sure exactly, you know, let's say you want to get this particular collision shape, you're not sure what the path is of your child node, you can just take the node and drag it and drop it into your script editor, and you'll see it does it for you, right? It fills in this whole path for you. So you can just drag and drop, oops, I want the score, right? Drag, drop, score, dot, score, equals string of score. Okay. So what this function is doing right here, right? This again is a function that is getting called when this signal happens, right? When an area enters the Area 2D, it's broadcasting out this message, and our player script up here is listening for that message and then is acting on it. It's updating our score variable and it's changing our score. The final piece of this puzzle is, you know, we just need to have an area that we can enter, right? We have this player scene, that's nice. We have this little main scene, also kind of nice. I think what I will do right now is I'll make a sprite, and I guess I'll use these weird pictures that came with the font that I downloaded. like, why does this font come with 7 posters, but it doesn't let me use numbers? I don't understand that. I think that's crazy. Okay, sorry, getting distracted. We're gonna make like a little pickup, right? So I'm gonna actually use an area 2D as the root node of this scene. I'm gonna give it a collision shape. And then I will drag in, I don't know, this dumb little squeaky McGeeky. And I'll scale it way down. Right. I'll go back to the inspector. I will change its position back to 0. I will focus on it. So if you have a node that you've highlighted, you can always hit F in the main viewport to focus your cursor, like your view on it. That's pretty handy for quick sort of navigation. I'll shrink it down even further, just because I'm trying to make something kind of like a coin here, so it really doesn't even matter too much. Then I will make a collision shape, like a circle. Oftentimes with your areas and pickups and stuff, you don't have to be perfect. It doesn't really matter if your player enters the space up here, so long as the player can't tell, then you're kind of good to go. So I'll just call this, like, I don't know, squeaky pickup. Squeaky pickup sounds bad, but that's where we are. So I've got my squeaky pickup, which I'm gonna save. Okay, and you can imagine this is kind of like a little item that I've just created, right? And I can now go back to my main scene. I can just drag in a couple of these squeaky pickups, I guess, move them around. And what you should see happen is, right, we have created this object, which is an area. And whenever an area enters this area, we're going to update our score. So when I run this project, now when I go and get these squeaky pickups, you'll see that I broke the game. Why did I break the game? Oh, score is not the property. Sorry, it should be text. So I'll save that. I'll stop it. I'm actually going to make squeaky pickup a little bit bigger. That's fine. That's fine. That's fine. Great. Save that. Run it again. Now we have squeaky pickups, and you'll see when we enter it, we see that our score goes up. However, we have a bit of a problem. I'm still disappearing from the timer. Frankly, I forgot about that. The other main problem that we probably caught was that these, it'd be great if these went away, right? It would be great if, I'll just stop. I'm going to take away the hiding the player, because I want to still interact with the player, right? So it'd be great if these areas like disappeared, right? We've already looked at the hide function, which toggles an item's visibility, and we've already, we're saying that this node, that this thing that comes in here is the area node itself, right? This is going to be the squeaky pickup area node. So what we could try doing is we could try saying area.hide, and we can run that. And we'll see that that looks good. However, it is not actually perfect, right? Because it's still technically there. You can see that I'm hitting it, it's just invisible. And we can even go over to the remote tab, and I guess this is another nice moment to talk about the difference between the local tab, which is whatever, this is the node tree of whatever scene you're editing, but the remote tab is the node tree of the game that is running. If you're running your game, right? If you're like out here trying to debug your game, the remote tab is actually the nodes that are loaded right now. And you can see that the problem with hiding this item, right? We can see it's hidden, but it's still there, which means all the code is still working, right? We're still picking it up and doing it. We hid this other one, right? But it's also still just sitting there. So instead of just hiding a node, oftentimes we want to delete a node. And the easiest way to delete a node from the node tree is to use this function called queue_free. And this is just going to remove it from the rendering queue, basically. It's going to delete it from the scene tree. So if you say anything.queueFree, it'll delete that thing. And so now we can say we can go and run this game again, and we can see that we have this little game where we can go and pick up this item, and it picks it up, and it actually does a nice job of removing it for us entirely, right? So I know that this is getting a little wonky. It's getting a little hairy. But you can already see how things are starting to be really useful, right? We're starting to have a sense of interactivity, of being able to actually kind of, you know, like use objects together in ways to like actually create meaningful interactions. And I guess what I will leave you with is a couple other really good use cases for collision shapes, right? Because we've already started to see collision shapes and how they kind of interact with Area 2D to allow us to create these areas, but I did say that we could use them for all sorts of stuff. So I'm going to create another example scene. I'll just call this, you know, I'll call this physics demo. Physics demo. And you might be thinking, oh God, physics. Which you would be entitled to think that. That's a very fair thing to think. Whenever I hear the word physics, I panic a little bit. But what's really nice about these tools is they abstract a lot of the work of dealing with physics for us, so we actually get a lot of really good physics interactions for free, right? And the reason why we even have to start talking about physics is because oftentimes in games, we want to be able to collide with things, right? Even if we go back to this main level, this sort of background stuff, right? Currently, we're just kind of walking. Oops, this is my empty scene. Sorry. Right, we're currently just kind of walking around as a picture. We're just moving this picture behind or on top of this other picture, and there's no sense of like hitting it and bouncing off, right? And oftentimes, if we have characters with constraints, right, and we're trying to create constraints in these games because we want there to be these sort of, you know, arbitrary challenges that we're doing as players, oftentimes we need to literally not be able to just walk through the walls. And so physics are actually a really important part of game design. And so it's important to get a little bit of comfort with approaching them, right? And so what's great about these collision shapes is they make this whole process really easy, right? So I'm going to introduce us to just, I think, 3 more nodes. The first one is going to be called a static body. And a static body looks, you know, kind of like one of those Mario platforms or like a bolted, it's like a thing that's like screwed in. A static body, we can read about it, it's a 2D physics body that can't be moved, right? So static bodies are just sort of stuck in space and things run into them. So they're really good for things like walls and floors. And so a static body needs a couple of things. We have the node itself, but you'll see that, again, you know, we don't have any shape to it. And this is where we do this thing where we add the collision shape node, right? And this is actually going to define the shape of this static body for us. So we have this collision shape, which now is going to do this thing where it complains how it wants a shape, okay? And so now we're going to make a shape, and I'll zoom in on that shape. I'll make it bigger, okay? And that's pretty good. The final thing we're going to want is, you know, this is the collision shape, but if we just ran this, you know, we wouldn't actually, well, sorry, wrong scene. If we just ran this, you know, we wouldn't see anything. We have the physics objects here, but this is a debug shape. This is just for us to see in the editor. So if we actually want to see our floor, you need to add some sort of image to be your floor, right? And you can use a sprite. We can use a squeaky poster. God, these posters are nuts. Like, I can't believe it. The font came with a t-shirt, but again, is not even letting me use letters. I think that's bananas. But sure, I'm going to make this the floor. I'm just going to shrink it way down. You know, this is just for examples purposes. And I'm going to make this roughly line up, right? And I'm going to make sure it's inside the static body. Then I'm going to click on this little movement icon, and now you'll see I have these little transform gizmos. Whoops. I'm going to click on the parent node and drag it all down to the ground, right? So I'm sort of making a very basic floor. And what this does for us, this static body, is again, it's an object that can be run into and bounced off of, right? And a great sort of example, you know, in order to prove that, let's get another physics object up in here called a rigid body. you'll see a rigid body is a cute little beach ball. You can think of a rigid body like a ball. It's a 2D physics object that just interacts with physics and moves around in the world. And you can get in there under the hood and, you know, apply all these gravity and impulses to it, but also it does just kind of work like magic. So for instance, if we took this rigid body, we gave it a collision shape, give this a circle, make it maybe that big, and give it a visual representation. And I'll make the shape a little bit bigger to kind of match the player or the whatever. That's fine. Yeah, sure. I'll save this and I'll run this scene, and you'll see kind of magically it just falls and it just hits the ground, and that's amazing. There's no code. There's no code over here. These are just nodes doing their own thing. They have these built-in properties that just kind of work, and by combining them together in different ways, right? By combining a collision shape with a rigid body and a sprite, we can actually create a convincing thing that feels like an object that exists in the world, which is kind of amazing. You can, while we're looking at rigid bodies, you can have a lot of fun with them. There's all these sort of fun little parameters which you can get in and fiddle around with, but you can do things like give them custom physics materials and make them like super bouncy and heavy. And then they bounce. You can really go nuts with them, right? You can sort of increase the scale of gravity for each of them. Yeah, and again, right, none of this is code that we had to write. It's just numbers that we got to fiddle with. And so we're already starting to see a really powerful kind of use case for these things. I know we're already at a lot, but since we're here and it's not quite 6 o'clock yet, I'm gonna just do one more node, and you can incorporate this into your brains whenever. But if we're already looking at rigid bodies and static bodies and physics objects, the final node we probably want to talk about today is a character body. And a character body is a fantastic node because it is it's kind of a combination of like a physics object, but you also use code to move it around and interact with it. And it is most useful in the context of literally being your characters that you are trying to use in your games. So, for instance, I think what I will do is open up this. What I'll do the following. I'm going to make a new scene. I'll make a new version. That's what I'm gonna do. I'll make a new scene, and I'm gonna use a character body as the root. You're going to see that it complains that it doesn't have a collision shape, so I'm going to give it a collision shape as a child. Okay. I'll also give it the robot. I said I'll give it the robot. I'll reset the robot. I'll make a collision shape that's about the same size as the robot. Okay, I'll hit save, and I'll call it physics player. Okay, and I'll hit save. Then what I'll do is I will create a new script, and nope, wrong node. I will click on the character body and hit create a new script, and you'll see that this particular node has a template built in, a very useful template, which I'll show you at the end. But for the moment, I'm just going to use the default template. And I'm actually going to make this a physics player, like sort of like an overhead, like a top-down controller. Okay. And the way that the character body node works is you, instead of just modifying your character's position every frame, what you need to do is instead modify its velocity, right? Velocity is a measure of how far you want to move at what speed, right? It's like how far you want to move over what period of time. And so instead of just saying speed, what we can do is, well, we can say speed. We'll say export var speed equals let's try 50, and then I think we can do this in the process function. We might need to use the physics process function, which is for physics calculations, but we'll see if this works here. We can say I'm just going to go back to my other code and copy all this. Copy, paste. But instead of position.x, I'm going to say velocity.x. This needs to be outdented. And then the final thing that you want to do is you call this magical little function called move and slide. And what move and slide does is it takes your velocity, right, how much you're intending to move, and it tries to apply that, right? Move and slide takes your velocity, moves you over that much, but then checks to see if you're hitting anything like a static body or a rigid body, and if it does, it'll just slide you off of that. So just by using velocity, by modifying our velocity and then calling move and slide, we get some really amazing interactive behavior already. Oh, I've already got questions. So Area 2D is the node that creates the hitboxes for objects. So collision shapes are kind of, you can think of collision shapes themselves as the hitbox for an object. This live stream definitely will be, God, I hope it will be. It better be. That's the whole point. It better be recorded. I think it is getting recorded. If it's not, we're all in trouble. But I'm very confident that it is getting recorded. That's the whole point. But the hitboxes, collision shapes are basically the hitboxes, and then we use them in different ways, right? If you are just trying to detect if something has entered it and then use code based off of that, you want to use an Area 2D. But if you want to sort of use the collision shape actually as a way to calculating like things bouncing off of each other, then you might use a node, a parent node, like a rigid body or a static body. Does that? I hope that makes a little bit of sense, and I hope you didn't ask that like 60 minutes ago. But yes, they are kind of like hitboxes. With a character body, right, we modify our velocity, which is just almost like our intention, right? It's not actually moving our position. It's like how far we want to move. And then we say, let's see if we can move with move and slide, right? So I have this simple script. I just want to change this level a little bit so that it'll work with our script. What I will do is go and turn this into a static body. Static body. I'll give it a collision shape. Collision shape. I will move this rectangle inside of it. This rectangle's all over the place. Layout. Oh gosh. Transform. Okay, great. We'll move this rectangle back to heaven. Where did it go? Where did this rectangle go? I guess I changed its size. Whoops. Okay. Position. There we go. Okay. All right. We have the static body. We have the rectangle. We are now just going to give a shape to the rectangle. That's pretty good. I'll call this block. I'm going to right click, turn it into its own scene called block. Then I'm going to delete all these other guys. Bye. Yes, go away. Go away. I don't care about the animation tracks there or anything. Then we duplicate it. And now we should have a couple of blocks, boink, that are actual walls that if we now move around with our code, we can bonk. Oh, right. So we're using our, right, this is our yeah, this is our player that is not physics-based, so I'm actually just going to delete this player from this scene. No, I'm sorry, because this is probably helpful to keep as a demo. So I'm actually going to take these. I will take this. Yeah, I'll take this whole thing. I'll make a new scene. So that way we'll have a demo that is both the picking up stuff and also the physics stuff. And then we have physics player. That's who we put in here. So now we have our physics player and our physics objects. I'll call this physics level. Okay, we can move around. We boink, but we bonk into things, right? And that's kind of amazing that we already have that. A couple things that you're noticing, right? This is actually really fast, right? And we also don't have our camera, right? So I'll put the camera back. But the speed is really interesting, right? The speed, we kind of can see that when we run this level, we keep gaining speed when we hold this down, right? And this is because what is happening is velocity is, right, our intention. Velocity is how far we want to move and how fast. And if we increase that over time, if we increase that while we're holding down our buttons, that's going to be a problem, right? That's going to say we're going to keep increasing the speed at which we want to move. So what we actually want to do when we're working with velocity is instead of increasing our position, you just need to set your velocity to the speed. And this is a really nice also example to use an else statement and a couple of else if statements. So we have our if statement. This is going to happen. Then we can say if this is, if we're pressing this, we'll do this. Otherwise, if we're not pressing that, we can check to see if we're pressing this. So else if is like else, right? If we do this, this happens. Else, we're going to do this. But else if is sort of like else if, right? It's like first we see if we're doing this, then we're going to see if we're doing this, and then we'll do that. Otherwise, we'll check to see if we're doing this. Otherwise, we'll check to see if we're doing this. And then finally, if we're not pressing any button, we'll just put our velocity back to 0. We'll say velocity dot y equals 0 and velocity dot x equals 0, right? So I'm doing this here because I want to be able to let go of the buttons and stop, right? And if we don't have a thing that resets our velocity back to 0, because we're just assigning it to our speed when we press the buttons, if we let go of the buttons, we need some sort of way to sort of reset, right? And so now we'll see that we have a nice kind of easy peasy movement. However, right, we see that we're going quite slowly, so we see by default that velocity kind of movements are actually fairly slow, right? So what we want to do is turn this up a lot by like adding a 0, and I sort of feel like I already did something bad. Yes, aha, we got rid of the negatives. So moving left, we want it to be equal to negative speed. Moving up, we want to be equal to negative speed. Okay, final try. We can move around, we can bonk into things. We're not accelerating like crazy, and we're able to stop. So this is not a bad sort of top-down character controller. And the final thing that I will show you is this template. This template is very powerful and is fairly straightforward. I actually won't show you the template. I'll show you the template for later. If you're thinking about making a platformer, though, know that Character Body has a pretty good template that's built into it that allows you to really get away with some crazy stuff. I encourage you to explore that on your own, and we'll see if we can figure it out together in next class. I also didn't have enough time to get to assets today, but I encourage you to start looking at animated sprite and tile sets or tile map layers to create some levels and some characters, and we'll pick up with that in our next set of classes. I know this was a really dense video with a lot of stuff in it, so please rewatch it. Change in velocity over time equals acceleration. That's exactly right. Yeah, that's how that works. And right, so there's a lot in here. Right? We're talking about physics, we're talking about collisions, we're talking about signals and functions. So there's a lot to unpack. Feel free to rewatch it and feel free to reach out. Please find me if you need me, right? You know how to get in touch with me if I'm not being responsive. I will do better. I've got my email fixed on my phone now, so I will get your notifications. Feel free to book office hours, and if those times don't work for you, feel free to book, to shoot me an email, and we'll find an additional time. I hope you're all doing well and staying warm out there, and I hope this code has been an interesting foray into our more complicated stuff we can do with code. Have a great week, everybody. I will see you all in the future. Ta-ta.